Hello everyone. I invite you all on behalf of ACE Online and ACE Engineering Academy platform to this session revision series of SSC JEE for the subject Theory of Machines and Vibrations. I, Faculty Muhammad Waheed working at ACE Engineering Academy Let us get started with the session. So here the SSC JEE exam is going to consist of 200 questions and that you have to answer in 2 hours, okay, and it will be having 200 marks. So here ACE Engineering Academy and ACE Online platform, they are conducting a mega mock test on 26th May and the fee is only 100 rupees. Kindly note this date guys, so that you can prepare very well for your examination. Now let us see what are the topics we have in this subject, Theory of Machines and Vibrations, and after that we will see the questions. So this subject will be consisting of topics mechanism, flywheels, gyroscope, gear and gear trains, cam and followers, balancing of masses and vibrations. Now here let us see what are all the subtopics within these major ones. Okay. So under mechanism chapter, the subtopics we have is definition of link, pair, mechanism and a chain. So basically here we will be having straightforward facts in this topic. Next is degree of freedom. So here we may have a numerical kind of a question. Next is Grashoff's law. This is also a question based on simple equation, that is L minimum plus L maximum is equal to, or it should be less than or equal to P plus Q, that is P and Q are the summation of links of other lengths. Alright. Next is inversions, and the last one is quick return ratio. Okay. So after this, next topic we have is flywheels, and we are going to see the application of flywheels for prime mover as well as punching machine. Next we have is gyroscope. So effect of gyroscope will be mainly focused on aeroplane and ship. Okay, and next is we have gear and gear trains. In the gear and gear trains we have the classification of gears, next is the nomenclature followed by interference, and next is the velocity analysis of gear trains. Okay, so next topic after this here we have is cam and followers. So cam and followers, basically it is going to consist of only classification of cam and followers and motion analysis of cam and followers. Alright. Next we have balancing of masses. Balancing of masses, we have only 2 categories here. One is the balancing of rotating masses and another one is the balancing of reciprocating masses. Next one we have governors. In the governors we have different types of governors, that is centrifugal governor and inertia governor, and more or less our chapters evolve around the centrifugal governor. Okay, and next is we are going to talk about the stability analysis, or we have already seen this controlling force or stability analysis in the governors. Alright. Next is we have mechanical vibrations. Under mechanical vibrations we have free undamped vibration, free damped vibrations, and forced vibrations and whirling of shafts. Alright, so these are the topics what we have in theory of machines and vibrations, and let us get started with the questions. So here is the first question, and we will try to solve this question in a time duration of 30 seconds. Let us see. When a relative motion between the 2 elements is completely or successfully constrained, then these 2 elements form. So here when you are forming a constrained motion between 2 elements, so when there are 2 elements we can only form a pair. Option C is the answer guys. We can only form a pair, but whereas in mechanism we will have more number of links, more number of pairs it is. Okay, and in the kinematic chain, the first link and the last link will be joined together. Okay, but none of the links will be fixed, whereas in mechanism one of the link is fixed. So as per the statement what is given in the question, here it is talking about 2 elements only. So it is going to form only a kinematic pair. So as per the question, option C is the answer. Okay, and one more thing, the machine is going to comprise of more than one mechanism. Okay, Machine may consist of one mechanism or more than one mechanism, but here mechanism is used for transmitting or transforming the relative motion, but machine is meant for performing the work as well. Okay, machine is meant for performing the work as well. All right, now let us move to the next question. When the two elements of pair have a line or point contact, when in motion and one element moves over another element, the dash type of motion is more likely to occur. So here it is saying that it is an already line or point contact, which means it is a higher pair. So in higher pair, we have only two possibilities: either rolling motion will occur or rolling plus slipping motion may occur. Okay, rolling plus slipping may occur because there may be loss in energy also. So both option B and C are correct. Okay, but option D is including both option B and C, so option D is the right answer. Alright, and whereas this rotation occurs in a revolute kind of a joint. Now let us move to the next question. A kinematic chain is dash. Option A says that combination of kinematic pair in which one link is fixed. As I told you earlier, when one link is fixed, it is going to form a mechanism. So option A is not at all the correct one. Option B says that the combination of kinematic pair in which each link forms a part of two pairs and the relative motion between the links is completely constrained. Combination of kinematic pair it says, okay, and here it is saying none of the link is fixed, so option B could be the probable answer. And option D says that same as mechanism. No guys, it is definitely wrong answer. In the mechanism we have one link fixed. Alright, next is option D. Option D is saying inversion. Inversion is obtained by fixing the different links, guys. Inversion is also not the correct answer. Option B is the answer, guys. Okay. Next is Ackermann steering gear is an inversion of. Ackermann steering gear, basically it is the combination or it is the result of 4-bar mechanism. Let me give you the description here. This is the L maximum or the link which is having greatest length, okay, but these two links are of identical lengths, alright, and this is link of some other length, but here these two are identical lengths. So this is a combination of 4-bar mechanism only. This is a combination of 4-bar mechanism or inversion of 4-bar mechanism, I should say. Okay, and the crank slider chain is not a correct answer. Okay, double slider as well as crossed slider are out of the context. So option B is the answer. Next one, choose the correct statement. The ordinary reciprocating steam engine is an inversion of double slider crank mechanism. No guys, it is the inversion of single slider crank mechanism. Alright, option A is incorrect. Next is Scotch yoke mechanism is an inversion of slider crank. It is the inversion of double slider crank mechanism. It is the inversion of double slider mechanism. So this is also out of the context. Next is quick return mechanism. Quick return mechanism is the inversion of crank slider mechanism. Yes guys, this is correct answer, because under quick return mechanism we have offset crank slider mechanism, we have Whitworth mechanism, we have crank and slotted lever mechanism. All these are list of quick return mechanisms and all these belong to single chain, that is crank slider chain or single crank slider chain they belong. All these three inversions. And option D says that number of inversions in a mechanism having number of links in a mechanism, number of inversions in a mechanism having number of links equal to L will be L plus 1. Number of inversions is equal to number of inversions is equal to number of different links. Please do remember, it is not the exact number of links, it is number of different links. And if you notice, let me emphasize on this statement. if you take an example of crank slider mechanism, in the crank slider mechanism, the link, let's say link number 1 is the frame, second link would be the crank, and third link will be the connecting rod, and fourth link would be piston. Whereas in the double slider mechanism or double slider crank mechanism, that is link number 1 is frame, link number 2 is the slider, link number 4 is also the slider, and link number 3 is the connecting rod. Now here you can see link number 2 and link number 4 are identical in nature, and that is why we are having 3 inversions under double slider mechanism, and we are having 4 inversions in the single crank slider mechanism. Alright, so please remember this statement. On this statement, on the basis of this statement, we are deciding the number of inversions. So option D is also incorrect. Option D is also incorrect. Alright, now let us see the next question. Next question, power screws are used to, this is a simple straightforward question. Convert linear motion into rotatory, not possible. Okay, option B says none of these. Option C says that both A and B, which is also not possible. It is used to convert rotatory motion into translatory motion for the power screws. Option D is the answer. Okay, generally we will be using these power screws in the screw jack or in the machine applications as well. Alright, now let us move to the next question. If the block slides outward on a link at a uniform rate of 20 meter per second and the link is rotating with a constant angular velocity of 40 radians per second, counterclockwise, the Coriolis component of acceleration. Coriolis component of acceleration is given by the simple formula A Coriolis is equal to 2 times of velocity of slider into omega of the link. So directly we have to do the multiplication, so nothing here else. So 2 into 20 into omega will be 40, which is equal to 1600 meter per second square. Option B is the answer, guys. Okay, let's see the next question. In the single reduction, a large velocity ratio is required. Best transmission is dash. So when we are going for large velocity ratio or velocity ratio which is ranging from 20:1 to 100:1, and that too you have to do it in the single stage, then the best suitable is only warm gear drive. Warm gear drive. Up to from 1:20 to 1:100 can be done in the single stage by using this worm and wheel arrangement. Okay, so for this question, option C is the answer. Whereas if you see the spur gear, helical gear and bevel gear, the size of the arrangement will be more when we are going for large reduction ratio. That is when we opt for worm and wheel arrangement. Okay. Next, the total number of eye centers of a mechanism having 8 links is equal to. Number of eye centers, guys, it is given by the straightforward formula, that is NC2, which is n into n minus 1 by 2, which is equal to 8 into 7 divided by 2, which is equal to 56 by 2, that is 28. Number of eye centers will be option B, that is 28. Okay. Next question. Which of the following pairs of parts can be considered as higher pair? So gear in mesh is an example of higher pair. Gear is called as higher pair, and even cam and follower is also called as higher pair. But this belt and pulley, it is a special case of higher pair, or which we call it as also wrapping pair. This is called as wrapping pair. Even chain and sprocket is also falls into under the same category of wrapping pair. Okay, so or else you can call it as even higher pair. Okay, so option C is including all the statements 1, 2 and 3. Option C is the answer. Okay, let's see the next question. The pitch point on the cam. Pitch point on the cam is associated with the pressure angle. Any point on the pitch curve? No guys, this is not the correct answer. Option B says that point on cam pitch curve having the maximum pressure angle. Yes, this is actually the definition of pitch point. And one more thing to add on, locus of pitch point is called as pitch circle guys. Okay, so pitch circle and pitch curves both are different. Okay, so here locus of pitch point is called as pitch curve for the cam. Next, option C says that any point on the pitch circle. This is actually the locus of pitch point. All right. Next is point at a distance equal to pitch circle radius from the center. So this option D is out of the context guys. Option B is the answer. Next, the cam profile and pitch curves are same for dash. Which type of follower do you have the cam profile and pitch curves as coincident? Now guys, here we have different types of follower: roller follower, knife edge follower, mushroom and flat faced. So let us do the comparison. So for roller follower, it will be definitely consisting of a rolling element, and whereas in the knife edge follower, this element will be absent. Now guys, here the trace point, reference point for knife edge follower is the point of contact, and this point is going to move along the cam profile, whereas the trace point here, it will be the center of roller follower, and this is going to move along the cam, and this we call it as pitch curve. Okay, this is called as pitch curve, and this is called as cam profile. But here in the knife edge follower, these two are coincident, as the radius of roller is tending to 0. So these two will be coincident in the knife edge follower. Option B is the answer. But whereas for the roller follower, they will be appearing distinct. In the mushroom as well as the flat faced follower, they will be appearing coincident guys. But generally speaking, we opt more, the B will be the correct answer. Okay, because for all these type of followers, for knife edge follower, for mushroom follower, for the flat faced follower, the reference point will be the point of contact between the knife edge or mushroom or flat faced. So locus of this reference point is called as pitch curve. Alright, so option B, C and D all are correct answer, but this is more probable, or this is more right answer for the knife edge kind of a follower. Option B will be the correct answer. Okay. Next one, in the Hartnell governor, if the stiffness of the spring is increased, the governor will become. So when we increase the stiffness, the governor will become less sensitive, because if the stiffness is reduced, governor will become more sensitive, or the sleeve displacement will be more rapid. Okay, so option B is the answer. The governor remains unaffected. Option C is also out of the context. It will start hunting. This hunting phenomena is associated with more sensitive governor. Okay. So for this question, option B is the answer. Next one, if the ball masses of the governor have same equilibrium speed for all the radii of rotation, which means that r is variable but omega is constant. Omega is constant. The speed of the governor is unaffected irrespective whatever the radius is. This kind of behavior or such type of governor is called as isochronous governor. Isochronous governor. Whereas in the stable governor, there is a different value of speed for every new change, for every change in the position of ball masses. As the ball masses, they are having some different, if they vary radially, then for that radial variation in distance or for the variation in radial distance, they are going to have different value of speed, and that is for the stable governor. And for hunting, this is associated with the highly sensitive governor. And sensitivity, yes, for sensitive governor and highly sensitive governor, both are different, but the sensitive governor can be stable, but highly sensitive governor will be prone to hunting. So prone to hunting means during the hunting, what happens is that the governor arms are going to experience violent oscillations, or that is when the governor is having resonance. So option C is the answer for this question. Next, if the ball masses of the governor occupy a definite specified position for each value of speed, then it is said to be stable governor. There is a unique value of radius for a different value of speed, then the governor is said to be stable governor. Okay. Option A is the answer. Next one, the maximum fluctuation in flywheel, fluctuation of flywheel is dependent on, so we know this formula very well, that is delta E is equal to I times of omega square into Cs. So the maximum fluctuation in energy is dependent on the coefficient of fluctuation in speed, square of the angular speed of flywheel and moment of inertia of the flywheel. So all of the above, on all these parameters it is dependent. Okay, straightforward questions will be given to you guys, and it is you can solve it very easily within a time duration of 30 seconds to 1 minute. Okay, some questions may have multiple statements, so it is just that you need to go through, or you need to have some practice. Next one, the angular acceleration and moment of inertia of flywheel is 1 radian per second. Alpha value is given to us as 1 radian per second square, and moment of inertia is equal to 1000 kg meter square. Moment of inertia is also given to us. Then what is the kinetic energy after 5 seconds from the start? They are asking you to compute the kinetic energy stored in the flywheel after 5 seconds of start. So omega will be equal to, that is alpha times of t, which is alpha is 1 into time duration is 5 seconds. This is equal to 5 radians per second. All right. Next is kinetic energy will be equal to half times of I omega square. All right. Now you can substitute all these values, that is I will be equal to 1000 and omega is 5. So 5 square into 1000 into 1 by 2. So approximately this will be around 12,500. Okay. This will be around, yeah, it will be around 12,500. So if we divide that by 1000, so it will be 12.5 kilonewton per kilonewton meter. Option B is the answer, guys. Option B is the answer in kilonewton per kilonewton meters. All right. Let us see the next question. In the gear, interference takes place. This is a very, very important concept. So interference, option A says that tip of the tooth of meeting gear digs into the portion between base and root circle. Yes, this is where the undercutting happens. This is the region where undercutting happens. Okay, and option B says that gears do not move smoothly in the absence of lubrication. B is out of the context, not correct point. Option C says that pitch of the gear is not same. See guys, the pitch of gear is circular pitch, which is PC, which is given by pi times of module. Pi is constant and a module should be same for both the gears which are in mesh. Option C is also out of the context. If they are not same, interference will occur. This is not the correct reason. When the gears are in mesh, they should have the same module. And option D says that gear teeth are undercut. Gear teeth are undercut. This undercutting is either the result of interference. After the interference has happened, then the teeth will have the undercutting. Undercutting means this portion from the gear tooth is going to be removed, and this could be the result of interference, or sometimes we are giving this purposefully in order to avoid interference. Basically, due to the undercutting, the strength of the tooth is going to be decreased. Okay, so option D is not at all the correct answer. When interference will occur, when the tip of the tooth of meeting gear digs into the portion between base and root circle, at the root side only this undercutting is happening. So this is what the statement 1 is telling us. Okay, option A is the answer. It occurs in this region only, between the region between the base and the dedendum circle or root circle. In this region only it occurs. Alright. Next one, question number 18th, that is a 3-rotor system has the following number of natural frequencies. 3-rotor system will have 2 natural frequencies. 2 natural frequencies means, here if we consider 3-rotor system, this 3-rotor system will have the vibration with the single node, will have the vibration with the single node. Single node in the sense, let's say rotor 1, rotor 2 and rotor 3. Rotor 1 and 2 are rotating in clockwise and rotor 3 is in anti-clockwise. Then the node will appear here. Then the node will be lying between 2 and 3. Let's say 1 and 3 are in same direction and 2 is in opposite direction. Then what happens? The shape or vibration mode shape will be something like this. Okay, the mode shape will be something like this. Let me redraw it once again. So this is going to have one frequency. This is with one node, and it is going to also vibrate with 2 nodes. So it will have only 2 frequencies, and it depends on how many how many nodes are being observed while the shaft is undergoing vibration, or while this 3-rotor system is undergoing vibration. So here the answer is 2 natural frequencies we have. This is under first node, and when there are 2 nodes, this will be the second natural frequency. So whenever the system is having only one node, we also call this as fundamental frequency. We also call it as fundamental frequency. Alright. Next one. The amplitude of undamped oscillation varies with respect to time as. See, undamped means no loss in energy. So no loss in energy means the amplitude will be sinusoidal. It will be undergoing to and fro motion, and to and fro motion can be given by only a sine wave. So option C is only the correct answer. Option C will be only the correct answer. Okay. Let us move to the next question. Swaying couple, traction force and hammer blow. These all are the results of partial balancing. When we go for partial balancing, all these effects will be visible. And more or less in the partial balancing, let me go to the basic. Unbalanced force is given by mr omega square times of cos theta plus cos 2 theta divided by n. This unbalanced force can be split into two components, that is mr omega square cos theta represents the primary unbalanced force and mr omega square cos 2 theta by n represents the secondary unbalanced force. Okay? But here the value of n is generally greater than 1, and for locomotives this value seems to be very large, and the effect of secondary unbalanced force or this term will be generally ignored. Alright, and now we will consider only the primary unbalanced force. This primary unbalanced force will be causing swaying couple, traction effort as well as hammer blow. So these two reasons together, primary force and partial balancing, because of the partial balancing we will see all these, and primary disturbing force will be also responsible for generating all these effects. So option D, which says both A and C, is the correct answer. So these are few questions from theory of machines, guys, and I have tried to cover some questions in the new form. Okay, and prepare well for your examination. All the best.